Hello, everybody, and a warm welcome to our webinar about the advantages, innovations, benefits of our new software version 4.0. My name is Benedict. I'm here at Cyprus for now 2 years, and I'm working here as the product management for our dental products. What I wanted to show you today are some simplifications of the measurement settings we implemented in our software. We have a new byte optimizer I will want to show you. Some new features we have in a view mode, some general changes we have. We have gradient circles. We have something new in the manual therapeutic position. The import of additional scans and new export options. Then we introduced a complete new measurement method in our system. We call it the simple or single calibration and maximum incorporation or with byte registration. We have a new attachment designer and splint designer. I will give you a quick overview and some new tutorials I will tell you. So let's start with the first step with our new simplification of the measurement settings. In the version 3, we have, when we go into measurement settings, a lot of options. We can choose how we want to measure the condyle position, the reference plane, if we want to measure the subnasal point at the camper plane by pointer or arbitrary, how we want to match the scans, and the vestibular scan with registration material method. For new beginners, new people who wanted to start with the system, this could be a bit overwhelming. So we hide some measurement settings for our beginners, and we are still left with our new method, the single calibration in EKP or byte registration method. For our people who are also already working with the system, or if they have specific use cases of the systems, these measurement settings, of course, are not deleted. They are hidden, and if you want to show them again, simply go into the program settings under dental, and for example, with the dental reference plane, you can again choose between the Frankfurt plane and the Kamper plane. X detection, for example, on the other hand, you can choose here how you want to measure the condyle position. By default, now it is the SIBO. When you enable this, you can again choose between the SIBO, the hinge axis, and the kinematic axis. One setting, the choose how we want to measure our upper jaw position, we did not hide it in the program settings. We put it at the beginning of each measurement. This helps our new customers to easily choose which option for them is available. Because not everybody knows what is the byte fork at the beginning and the alignment fork, and here you see with the icons exactly what you get. Our byte optimizer. A huge problem in the digital dentistry is that when we make an IO scan, that's the vestibular scan on the side, when not perfectly done, we have intersections in our scan. Sometimes at first we see this in our SIBO software when we imported the scans, that we have here some big intersections, and when we go forward, we will give this error we have here our technician, and for example, in our prosthetic work, we will still have this mistake. So you don't have to make a new scan, with your patient. We implemented this, we call it byte optimizer. When we are at the software where we imported just the scans, we have on the right side this button adjust scan position. Here we find an algorithmic cleaning of intersections with the outer range gap button, where the software will calculate a new position of the lower jaw without intersections in the upper jaw. And you will directly see what the algorithm calculated for you, what the algorithm changes, yeah, from before and after. And if you say, no, it was not good or was too much, too less, you always are able to adjust it on your side or say, let's keep what I had from my IO scan and work with this data. How can this look? For example, we have here an IO scan with a lot of intersections, and with one click we removed all these intersections and have a clean occlusal surface for our measurements. Then we have new features in our view mode. Our goal is to keep it as simple as possible. So we reduce the buttons you find on the toolbar on the right side in the software. We combined all the occlusal contacts buttons with the section cards. We make the play button more easily accessible. And we also added, of course, the button for our new splint design. When we want to get good values from our patient, we always have to do more than one measurement of our movement, more than one protrusion and lateral movement. Till now, it was that we have to we click start, make the movement, click stop, and then again click start, make movement and stop. With the new version, we make it really simple. You simply say, you click start, and say to the patient, move forward and back, forward and back, forward, back, forward, back, and click stop. And in the viewer, you get 4 separated protrusion movements, which we'll use to calculate articulator values and parameters of your patient. In the version 3, we offered you the side view and the front view for the curves. With the version 4, we added it to the side and top view of our patient to have a better understanding of the bended angle in our movements. A lot of patients we measure with our systems have problems with stability and condyle positions. To give you a first indication if a patient is stable in his bite or how much movement he has, for example, in the radial movement, we added our gradient circles. These you can activate to get a first indication about the stability and movement possibilities. We also added in our manual therapeutic position, not only before we had only the protrusion and opening movement, now we also have the retrusion and the closing movement for better positioning of the lower jaw for your therapeutic treatment of your patient. And a big new feature is that, of course, we can now handle multiple scans of our patient. For example, what you see here, we imported just STL DICOM files into our measurement, and you will later see it in the software directly, how you match these data and what you can do. We have new export of possibilities. More on the orthodontic side, we have here Onyx and Shoei Dental. But what you don't see here, we also have now a connection to 3Shape. This is now possible. It's a bit basic, but we will work on this. To give you a better understanding about upper jaw positions when you also want to work analog or digital, we implemented the feature that when you measured with the bite fork, that you can display the articulator directly in our software and see, depending on the measurement and on my patient, what are the upper jaw position in the articulator. But when we will show you the articulator, for example, the Artix articulator, it will be not in a plane like on our screen. So we also implemented the feature that you can change between the reference planes in the viewer. So you can see what the curves and the positions of the models, the scans, will be look, for example, in the SRM articulator when you want to see the Frankfurt horizontal plane. As you see here, also the movement tracks also shifting the angle. So that's about the basic new features, and I would say also to give our new people a quick demonstration of the system that we will do a quick measurement, and I show you all these new features directly in our software. So let's change, and there we are in our software. Let's select the patient and go to measure. Here we have our functional digital occlusion module. Here my measurement setup, and when we go in here, we see it's much more clean, more easily accessible than before. We have some positions here selected, and as you see, only one movement of each recording. Okay, so let's start. I started the measurement, and as I told you, the first question is now that we select how we want to record the upper jaw position. For now, I will select the alignment fork. And there we are. Also, a new feature we have here is that when you already made a measurement with your patient, you have the scans imported into the previous measurement, these scans were automatically loaded for the new measurement. You could change them out, but if you don't want to, you can skip the import routine. So let's start the measurement. I will place this on my head. Like this. And I choose the SIBO, as the software tells me. Place the sensor in the front, and we start with the left ear. The right, and subnasal point for our camper plane. Next step is the positioning of the upper jaw. Use the alignment fork, place the sensor on top. And now we are here. We have to say that our scans now are in the right orientation, that we see the teeth. Can go next, and now select the pointer in the front, align it in the back, and we can go on. And now we are here at this position I already mentioned, where we just imported our scans, and now we can here, our adjust scan position, access our byte optimizer. And when you see here, we have some little intersections here. And when I click now, the button, the algorithm just cleaned these intersections, and we see it moves my lower jaw about 0.13 millimeters downward and about 0.2 degrees to the side, and also here was minus 0.12 degrees in this direction. This looks really good, and we can say we go back and go on with our measurement. Now we are here in our live preview. This preview we can really good use to train with our patient. What is a protrusion movement? Is the sensor fixed to the lower jaw? All these kinds we can test here. So let's place this on my lower jaw. I close my teeth and we press start. And now you see me here on my screen talking to you with my scans moving. We have here our dynamic occlusal contacts. And of course, also the dynamic contacts in the movements. Perfect. So let's go next. Here we are in the recording of our lower jaw positions. At first, we have to define our 0 position. This is our closed position. Then a read well position. And again, a maximum intercuspidation. A relaxed position. And we are done with our positions. And this looks good, so we can go on. Then we are in our movements. And now you will see when I press start, I will do the movements multiple times and then I will press stop. So, I close my mouth. Four times and 4 times to the left. And 4 times to the right. Then we have our opening. And our tooth-guided movement. The tooth-guided movement is a movement under tooth contacts with small movements in every direction. So our dental technician can use these movements to dynamic grind in your prosthetic work. And so we are finished. We save everything. And there we are. As you see now here in the top line, we have not only one protrusion, we have of course our 4 protrusion, the 4 left movement, the 4 right movement, and our 4 openings. And of course our tooth-guided movement is still one movement. I already mentioned that we combined our occlusal buttons, but before I start with this, let's remove the system so you can understand me a bit better. Okay, so before in the version 3 we have individual buttons for these analyze methods. We combined them into one to make it everything a bit more clear. But the functionality is still the same. So when we take a look here at our occlusal button, we can select between the current occlusal contacts, the summarized contacts, and the frequent occlusal contacts we see here. And of course, we also have here our section cut for a specific analyze of a specific contact. Then we have our manual therapeutic position, where we see here we have not only our protrusion movement, but also the retrusion movement, our opening movement, and our closing movement. When we take a look at the tracks, we have here now our measurements of the positions. And we have here our new button for our gradient circles. So we can directly say something about the stability of my first measurement of the maximum intercuspidation and my second one. Yeah, it's definitely in the green area, so it's really good. And we have here my read wheel position, and this is also still in the green area, so really good. Then we have here down in the export, of course, the export about ONXF and showing. About these exports and also to the export of 3Shape, there will be coming standalone videos how to export the data of ZBrush and how to import them into these CAD/CAM programs. Also about the Splint Designer, I already mentioned, there will be a quick introduction now and a standalone video in the next few weeks. So now I already say here we have the possibility to change between the planes. Here I measured in the camper plane, but here I can, for example, select the Frankfurt horizontal plane and see how my scans will look with this plane. And when we take a look at the tracks, also the tracks will change in the angle to the horizon, depending what reference plane we choose. And when we take a look at a measurement with with a byte fork, we have now the possibility to show you the articulator and the positioning on a mechanical articulator directly in our software. And so the articulator is also in a plane. We can select it here and we see the Artex works with the patient plane. This is the scan positions we have here, and we have an Exocad, for example. This we have for the articulators. We can also calculate the parameters. For example, we have here the SRM, which works, and the axis orbital plane. We can change it and see how our scans are placed in the articulator. Before I forget it, I already told you that we changed the angle of view in the tracks. In the 3.0 we have the side view and the front view. Now we have the side view and the view from the top of our curve, so we can say something about the blended angle in the movement. Perfect. So these are the new features you can use for the measurement, and now I want to introduce you to our new measurement principle we will introduce with the version 4.0. We call this principle the simple single calibration and maximum intercuspidation, or with byte registration. Simply means that we now have the possibility to measure one time the maximum intercuspidation, and from this step we have the possibility to start the movement from any position we like. So when we have a patient with no stable maximum intercuspidation, you will directly see where the patient starts its movement according to the first measured maximum intercuspidation. This allows, of course, conclusion about stability and reproducibility of the final byte. And also, you have much more possibilities in your measurement, because now you have the possibility, for example, only recording a close movement, or make a movement with a splint inside, so you can check if your positioning splint, you just get from your dental technician has the effect for your treatment as you want to have the effect, what you're looking for the effect. Also, in our measurement settings, we have some adjustments, because when you select this method of measurement, you have now the possibility to mix jaw positions and movement and place them in any order as you like. Already, same example, for example, with the splint, record as the movements, yeah, with, without the splint, record the movements with the splint, compare them together, and see if, for example, the displacement of the discus is not longer there when you have the splint inside. Let's show it to you. Let's go back to database, into measure, and again, let's take a look at the measurement settings. Here we see I have selected this single calibration in DKP or bite registration material method. We have the classic, at first the opening, protrusion, left, right, then our positions, and I have here the position of a splint and the movement of a splint. Then our tooth-guided measurement, and everything you like you can add here, of course. So, let's start this measurement. Click on Start. I will place the face bow on my head. And because I just removed it from my head, I have to click here, re-enter line and points to make a new definition of my camper reference plane. Take my sensor, place it on the SIBO, and let's start again with the left ear, right ear, the porian point, the subnasal point, and our upper jaw position. The alignment is good. Mark my reference point. Align it a bit in the back. And there we are. Now we are here directly in the measurement, not in the test movement, where the software asks about our scan position. But why scan position? Because we can use this measurement with a patient where we make the vestibular scan in occlusion, or for patients who don't have a stable occlusion, yeah, and we would get a lot of intersection when we make with this patient a normal vestibular scan. You also can make now the vestibular scan with a stabilization of a bite registration material, so get a clean vestibular scan. And we now use the software to measure this open bite with the registration material here in the software. In my case, I have a closed bite. And would you measure the scan position with the open bite, you can now close to a static maximum intercuspidation of your patient and close the bite. Then we are in our live preview, and you see now I will open my mouth and press then start, and you will see the result directly on the screen. And normally for our users, you know that when your patient opens the bite and you click start, you will get a lot of intersections in the measurement. This we don't have here anymore. The measurement you can start in any direct position you like, and the software will understand it. Then we start with the opening movement. Again, 4 times. Now protrusion. The lateral left movement. The right movement. And then we are in our positions. At first was the readable position. The maximum intercuspidation as a check. The rest position. And now, as I told, the position with a splint. I have here a splint of our new module for the upper jaw. Let's place them inside and make a measurement. And now record some movements with the splint. And a tooth-guided movement without a splint. And then we also finished with this recording. Close it and I will remove the hardware. And let's take a deeper look in the recordings I just made. Maybe you just saw it in the recordings that I did not make some really clean movements. Yeah, for example, here in the protrusion, yeah, I start. Then here I start not in the closed position. Here I didn't go back completely. Yeah. So as I would be not stable in my position, I just recorded my movements. And what we see here, that when we do this, that the beginning of our movements are not in the zero position, because I didn't start at zero. I started from a different position each time, and you will see the difference in the starting positions directly here in your tracks. And also a reason we implemented these gradient circles, so when you let your patient make a movement multiple times, you can see how stable their starting position is. And if they're still in the green area, everything is good. If it's in the yellow or red area, take a deeper look at the condyles and occlusion of your patient. Here, for example, also the movement of my splints. And you see I just added here my splint. There is our positioning of the splint. And here we have the dynamic of the splint. So again, the example I just mentioned, you have a patient with a disc replacement of the discus. You created a positioning splint so they don't jump off their discus anymore. Make a measurement without the splint, with the splint, compare them together and see if the splint has the effect that your patient did not lose his discus anymore. Perfect. So now I want to give you a quick introduction in our two new modules, the attachment designer and our splint designer. This will only be a quick introduction. For the attachment designer and splint designer, there will be separate videos coming out in the next weeks. So you get a deeper introduction into these modules, how to create attachment and how to create a splint. So, attachment designer. What is it for? Why we implemented an attachment designer? Basically, it's to design attachments directly in our software. Simple and easy. You have the possibility to import the models, the scans of your patient before the measurement, so you don't have to re-import them again in the software. And the really cool thing is that you can use this attachment for measuring the upper jaw position of your patient. So you will skip one step in the measurement with the preparation of an individual printed attachment. The design workflow is really simple. You import the scans, mark the area where you want to have attachments, and positioning the adapter in the front. You could place some holes onto the attachment to insert some adhesive material through the attachment, and you can also place some text on the attachment so you know which attachment belongs to which patient. How we can measure the upper jaw position with the attachment. In our software, we have a definition where the attachment is located to the lower jaw. We have with our UN adapter and plate a defining position of the plate to our attachment, and also we have a defined position of the attachment of the sensor on our metal plate. And when we combine it together, we can now calculate from our attachment from our sensor through our attachment to the lower jaw, and through our I/O scan, we get the positioning of the upper jaw. When you designed an attachment for a patient, and when you start your measurement, you will now see this attachment you just created for your patient as a method for the upper jaw position selected, and you will get a really clean and fast workflow with the system. Then we have our Splint Designer. With the Splint Designer, we want to give you the possibility to create simple and easy splints for your patient as a first treatment for pain issues or pain issues with your patient, of course, from a disc replacement of a discus or anything else. You can create splints in our software. We have two types of splints. We have the CTS splints, the comfort therapy splint, and the PTS splint, the positioning therapy splint. And they are really simple of the occlusal surface, but with the CTS splints, it's really easy to design because you select the lower jaw, define the positioning based on the opening movements of your patient, and you have no manual placement of the discus condyle in our software, like you know it from the manual therapeutic position. With the PTS splints on the other side, you have every possibility. Yeah, you can place it at the upper and lower jaw. You can place the lower jaw depending on the protrusion, retrusion, opening, closing movement, or make a manual placement of the condyles by hand in the software. The design is also really simple. On the CTS splints, positioning in the lower jaw is fixed, so you're defining you position the lower jaw at the position you want. We have the insert direction to define. We define the outline of our splint, and the software will give you directly a finished surface for your splint. You can accept, modify, grind in as you wish, but your software will give you a first succession for a splint you can accept and go straight to your milling machine for the fabrication. With the PTS splints, you have one step more where you decide if you want to place the splint in the lower or upper jaw. after this, you place the lower jaw in the positioning you want, insert direction, splint outline, and you can edit the surface. So, this was everything I wanted to tell you today. For now, I will give you a quick summarize of everything I just told you. Yeah. We have the revision of the measurement settings for easier access. We have the byte optimizer. We have the segmentation of motion recordings. We have the gradient circles. We have the additional selection of retrusion and closing movement in the manual therapeutic position. We have the import of additional scans, new export options, and this dynamic mode, or as we call it, the single calibration and maximum interpretation or byte registration method. We have our attachment designer and splint designer. Before we come to our questions and answers, here are my upcoming tutorials which will come out in the next few weeks. I will give you a tutorial about the attachment designer with the creation, printing, and use for a measurement. Also on the splint designer, yeah, how to create the splint, about the production, and what options you have, for example, in the measurement. I will tell you everything about the ONIXF export, how to export the data from our software and import them into ONIXF. Same site also for 3Shape and Shoei, where I show you how to export the data from our software and import the data into Shoei Dental and 3Shape. So now I'm open for all your questions. Please write them in the text. I will see in the chat. We will see them. We will show them to the other people and answer them, of course. Also, this tutorial, this webinar you just saw here will be also available on our YouTube channel in the next few days. Also this, because I think this question will come up, this new version 4.0 will be available in the next week, where you can get it from your local dealer and check out the new features. No questions, really great. So if you don't know where to type in the questions, when you go into Zoom, you have at the bottom line this button with F and A, yeah? In German, Fragen und Antwort, or when you have the English version for, I think it will be called questions and answer, where you can type in your questions. Thank you very much. Yeah, Lucas. So I give you a bit time because we are not in a hurry to think about what I tell you. Or if you say, can you repeat something again? It was a bit quick. Please write it in the chat, and we can do this and go through it again. Yeah, let's go again. Um, let's talk again about the Byte Optimizer. Let's go back to our software. There is my mouse. In the database, select our measurement. And of course, we have the possibility after a measurement to change or to replace scans. Yeah. Oh, one feature I totally missed to show you. When we go here to the import button, we have here also a new button to import additional surfaces. So let's talk quick about Byte Optimize, and then I will show you this new feature. So when we import new scans, we are in the same routine if we would import them during our measurement. We have to say that teeth are aligned correctly, so the teeth look at us, and we mark again our point, align it, and here. So this is the occlusion we just get from our I/O scanner. We see we have intersections here. Yeah? It's not perfect, not so bad, but not perfect. And this could be far worse. And then you have to decide during the measurement, can I work with these scans or have to stop the measurement, make a new I/O scan, and the treatment will get really long. So you can simply just click here on Adjust Scan Position. And now what we see here, everything is at 0. Now, each position you can manipulate by hand is at 0. And what will happen when we click here on Auto Arrange Gaps, that the system will calculate a new position of the lower jaw based on the possibilities that we can move the lower jaw in every direction. So we move it a bit down, change the angle a bit to the side, and also on this side. And when we see this and we say, no, this I don't like, let's go here about a bit less, or way more. For example, let's type in 0.5. You will see what will get changed, and you can manipulate it, edit it, or simply say, yeah, looks better because we have less intersections, and these intersections you will always have also in your prosthetic work when you give these scans with intersections to your dental technician. Good. I hope this was a bit more clear and easier to understand. And how it works. There is no KI or artificial intelligence behind it. It's simple math behind it. So it's not a black box. Because when you, as I told, when you click here, you see directly what, based on this algorithm, got changed in the occlusion because of the movement of the lower jaw. Good. And import, I hope this was clear, and if not, please write it in the chat and I will try to explain it again. New feature, import additional scans. I forgot it sadly before, but I can show it now. When we click here, import additional scans, we can import a new upper jaw, and I have here, for example, my STL DICOM files, and these I can now match at first here with my I/O scans, and this could be DICOM files. This also can be a first prototype of prosthetic work of your dental technician you can import in our software. or simply some scans. You have complete freedom what you want to import here. Then we import our lower part. There I flag the scans already in the same coordinate systems, so we can skip it. And there we have now our DICOM files in the software. And of course they are moving. Why should we think this is better? When we are using the byte optimizer, I think is the question. Intersections we get from movement of the patient during the vestibular scan with our IO scan. So when we capture the side view of our occlusion, and the patient moves, we will get a false occlusal contacts in our scan. These are the contacts or near contacts. For example, the green area is about 0.1 to 0.15 millimeters. And these are the contacts we have on our scan. Yeah, so we don't have any intersections. And of course, you don't have to use the byte optimizer for this. Yeah, if you say, I know I can do good IO scans, yeah, please use your scans you just made. Yeah? But if you have big intersections and you can't remove these intersections later on because you want to make your measurement, you want to give the data to your technician, we give you a tool to reduce the intersection, delete the intersections in your IO scan. So your dental technician has clean data he can use in exocad, for example, and don't have to manipulate by hand to get rid of these intersections or manipulate the surfaces of the teeth to get rid of these intersections. It's simply, I would call it the mistake, the digital dentistry, because of the intersections we measure or scan in an IO scan, we will always see later on, or most of the time, in the prosthetic work for our patient. Next questions, or is there something open? We have a few minutes left. The DICOM files, because at the moment we only can import STL, additional STL PLY files, so you have to convert. So for everybody, the question is, the DICOM should be prepared by the technician in exocad, for example. We cannot import directly DICOM files at the moment in our software. This is a feature we want to give you with the next version, the 5.0. For the moment, we recommend that you can use some free software which is out to convert your STL, your DICOM files into an STL to import it in our software. Ask your technician to use exocad to import these data in the software. There are multiple options you can use. A good question, can we import Cypress data into InLab? Sadly, I have to say no. We have no connection to the Sirona InLab system. We have the module for the CEREC articulator where you can get the values for the CEREC, but also here we have no direct connection. We have to type in these values by hand. So also in the InLab, you could use the articulators we give you, but we have no possibility to directly import the aperture position or wheel movement data into the InLab software. Yeah, the 3Shape is limited. At the moment, we have a basic connection to the 3Shape software, where we can import our aperture position, wheel movement data, static positions, everything, but what we can't import at the moment, and we are working on high demand on this, is that you can automatically import also the articulator values into 3Shape. So everything is possible, but not directly import of articulator values. But also here I will make a detailed video what you can import, how to export the data from Cypress, and everything. And if there is no question left, now is your chance. I want to say thank you for everybody to go through this webinar with me. It was a pleasure. And if there come up some questions, please don't hesitate to comment on the YouTube video, which will come up in the next few days. And we will, of course, answer all your questions there. Then I hope you all will have a great day or already had a great day, depending where you are in our beautiful world. And I wish you a great night, morning, and a lot of fun with the new version of our software, and also happy measuring.